Good evening, guys. So today we'll basically be talking about how to draw the structure of your nitrogenous bases and how to know if this is one of the nitrogenous bases or not. And don't forget, we have two main categories of our nitrogenous bases, which are the pyrimidine and the purines. So how do you know if this is under the purines and this is under the what pyrimidine? And a short what formula for you to what get them. Okay, this is a pyrimidine and this is a purine, and how do you draw the structure in an easy peasy way? Trust me. So now for you to understand this, the first thing, okay, let's start with the pyrimidine. Okay, so for you to understand the structure of the pyrimidine, the first thing you need to know how to draw is the structure of your benzene, and I'm very sure you know how to draw that. So how do we draw the structure of benzene? This is our benzene ring, this, right? We are all familiar with this. Don't forget, we have a carbon here, carbon, 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 and carbon. So this is the structure of our what benzene. That is that about benzene. So now after benzene, the next thing you need to know is the what we call pyridine, not pyrimidine now. So we have something called what pyridine. So what is pyridine? Pyridine is also a benzene ring. Okay, it also looks like a benzene, but the only difference between them is that in pyridine, one nitrogen has replaced one of the carbon in benzene ring. That is the only difference between them. In pyridine, one of the carbon has been replaced with a what? A nitrogen. So we also have something like this. Okay, so we have carbon, 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 carbon. Now instead of having a carbon here, we will have a what? A nitrogen. So this is a what? A pyridine. This is what? Pyridine. And don't forget, we also have this, and this. So you can represent it with your what? Circle, stay the same thing, okay? But like I would like to use this because of the explanation. So this, and this stay the same thing. So this guy is called what? This is benzene, right? Benzene. What about the next guy? The next guy is called what? Pyridine. Pyridine. And I am pretty sure you guys can draw this the pyridine now. Your pyridine is just your what? Your benzene ring and what? But one of the carbon in the benzene ring has been replaced with what? A nitrogen. Now let's move on. The next thing you need to understand here is, now let's go to the pyrimidine. Okay, we have something called the pyrimidine. The pyrimidine. Now, when you look at the structure of this pyrimidine, you will notice that what? I can bring out pyridine. I can bring out pyridine from what? Pyrimidine. From here, I have pyri. Okay, pyri. Here, I have din. Okay. So now bringing it down, I have what? Pyridine. Pyridine. So it will remain what? Mi. Okay, pyrimidine, we can bring out the pyridine. That is to tell us that what? One of the structure we want to draw should look like this, because we've been able to what? To extract or bring out the what? Pyridine from what? From the pyrimidine. So we are left with what? Mi. But I'm not seeing this as Mi actually. I'm seeing this as what? M and 1. I'm seeing this as what? M and 1, which I can interpret this as what? 1 more. I can interpret this as what? 1 more. Now what do I mean by this 1 more? That is what? Add 1 more nitrogen to your what? Pyridine. Do you understand it? That is 1 more. Add 1 more nitrogen to your what? Pyridine. Then you get the structure of your what? Of your pyrimidine. Are you with me? So I will have to clean this. Okay. So don't forget, you know how to do the structure of your benzene, then the structure of your pyridine. So now moving to the pyrimidine, just add 1 more nitrogen to the structure of your what? Pyridine. So okay. So I will have to like put that here. So now we're about to draw the pyrimidine rather. No. Sorry about the structure. So we have this. Don't forget. So we have one nitrogen here. So we have to add one more nitrogen to it. So I can put the nitrogen here. So this is our what? Pyrimidine. But now the question is, how do I know where to put the nitrogen? Are you with me? So this is our what? So this is not benzene anymore, okay? You notice that what your pyridine and your pyrimidine looks alike. So this is what? Pyrimidine. Okay. Now the pyridine and the pyrimidine, they look alike, and the only difference between them is just one more nitrogen. But how do you know? How do you know where to put the next nitrogen? You can actually put the first nitrogen anywhere, but how do you know where to put the second nitrogen? Now we have to go back to this. So now pyrimidine, what is the shortcut for pyrimidine? The shortcut for pyrimidine is COT. Okay, I mean the nitrogenous basis under pyrimidine, which is very popular. This is very, yeah, this COT is a very popular mnemonic for it. So we have COT, which is what? Cytosine, Uracil, and the Thymine. But that is not what I need that now. I don't need that now. What I actually need is this, and that's what I'm about to do now. So this is 1, 2, 3. We have how many pyrimidine? We have 3 pyrimidines. We have the cytosine, the uracil, and the thymine. So we have 1, 2, 3. It means that when you have your carbon, your nitrogen at number 1, the next nitrogen should be at number 3. That is 1, 2, 3, just 3. So 1, 2, 3. You place it here. Or if you don't want to place it here, just count 1, 2, 3. You place it there. Okay, that is how to know that okay, this nitrogen should be here. That is 1, 2, 3, 1, 2, 3. Okay, so this is how to draw the structure of your what? Of your pyrimidine. That is a basic pyrimidine ring. So we have different types of pyrimidine. We have the cytosine, the uracil, and the thymine. So how do you draw this? How do you draw this? How do you draw this? This is the basic structure for all of them, right? So how do we draw this? How do we draw this? How do we draw this now? Let's move to that side. So let's move to that side. Now, looking at this cut, okay, I'll use this cut to explain the structure. Now, I have cuts CUT. Now, the first thing I need to do here is that what? I need to bring out a basic structure from these 3 guys. I need to like bring out one. So from that one, I'll be able to draw what others. So I'm going to use this U. But why am I using the U? I have my reason for that. Because when you look at these guys, there are 3. So the one in the middle is the U. Also, apart from saying the one in the middle is U, you notice that what we have 2 consonants here and a single vowel. So the U is the vowel. It is the only vowel there. So you have to use your U as the what? As the basic one. Which from this U, you can draw others. From this U, you can draw others. Now, looking at it, that means that what? After drawing the structure of my U, if I want to draw for T is after U here. It means that what? I have to add something else to my U. Do you understand? But if I want to draw for C is before U. I have to remove something from that. Do you understand that? So let's do that. So we have to draw the U first. So what are we drawing in the U? So how do we draw the U? You all know that this is the first thing you have to draw. So now the next thing is you adding 2 oxygen. That is 1 oxygen here and the 1 oxygen in the other side. But where do you add the oxygen? How do you know? It's still the same thing. 1, 2, 3. When you add the oxygen in a particular place, count 3, then 1, 2, 3. You put the oxygen in the other side too. So let me use this side. So I have an oxygen here. So I will then count 1, 2, 3. So an oxygen should be here. So this is the structure of our what? Uracil. Uracil. But mind you, oxygen is supposed to have how many bonds? So just look at where I'm going. Oxygen is supposed to have how many bonds? 2 bonds, right? That means that what I'm going to bring this bond, I'll bring it here. What about this? It's supposed to have how many bonds? 2 bonds. So I'm going to bring this bond, I'll put it here. It is only this bond that will still be there in this structure. Do you understand what I did? I added, initially there was not there is no oxygen there, so I have to like add one oxygen here and put one oxygen here. But I know that oxygen is supposed to have two bonds around it, right? So I have to like, for here I'll bring this this double bond here, this bond here, I'll bring it here. Okay, I'll bring it here, and for here this bond here, I'll put it here, and because there's nothing attaching to this side, I'll have to like leave this one here. So this will then be converted to, okay, the black guy. Okay, we have a nitrogen. We have a nitrogen. Okay, okay. Anyways, yeah, let me just put nitrogen at the right hand side. You can actually basically put it anywhere. I want to put it in the place I put my oxygen. Okay, so let me have, I'm coming, sorry, nitrogen. So 1, sorry, 1, 2, 3. So the next nitrogen should be here. The next nitrogen should be here. So what about the oxygen? I can add one oxygen here. Oh, 1, 2, 3. I'll add another oxygen here. Okay, but don't forget this bond, we have to come here. Okay, what about this one? It will join the oxygen here. Okay, okay, but this bond will still be there. So this is the structure of your what? Uracil. And I hope you understand that. Okay, so I don't have to like draw any other structure again. If I want to draw the structure of thymine, okay, thymine is just what? Our uracil with what? A methyl group. Okay, thymine is just a uracil with what? Methyl group. So just add a methyl group here. So I have to clean. Okay, let me just draw it somewhere here. So look here. So nitrogen, right? One nitrogen here, 1, 2, 3. Where are we picking that 1, 2, 3 from? Here, 1, 2, 3. Okay, don't forget. So the oxygen also 1, 1, 2, 3. So I will have an oxygen here. Okay. Initially, I should have something like this. Okay, but because this guy is going to take one bond, I will have to clean the one here. Okay, what about this guy is going to take one, so I have to clean the one here. So this is still our uracil. So adding CH3 to this end, CH3 will give you the structure of your what? Of your thymine. Do you understand it? So your thymine is just a what? Uracil with what? A methyl group, and I hope you understand that. So now let me draw the structure of, okay, let me write it. This is uracil. So this is thymine. This is one of our nitrogenous bases, I mean under the pyrimidine. So the next one is the structure of our cytosine. How do we draw the structure of cytosine? How do we draw the structure of cytosine? How do we draw the structure of cytosine? Cytosine, very simple. Now, how do we draw the structure? We draw the structure of cytosine by saying, okay, a normal uracil should have what? 2 oxygen added to it. But for the uracil, it is at the back of this U. So I will not add 2 oxygen to it. I will only add what? 1 oxygen to it. And what am I going to what will I use to replace the oxygen I removed? An amino group. So let's do that. Our basic structure, we should have nitrogen. Count 1, 2, 3. 1, 2, 3. Okay, put your oxygen. Okay, okay, because this is cytosine. Cytosine is before the U, so it will not have exactly what the U has. Okay, it will not have the double O. So instead of the next O, what are we going to add? We are going to add an amino group, which is NH2. NH2. Okay, don't forget this one is supposed to have a bond here. Okay, that is your normal benzene stuff. Okay, but The oxygen here, we have to take this bond, okay? So I don't have to put it there anymore. I will put the bond here, okay? Do you think this nitrogen will take this? No. Nitrogen, how do we draw the structure of ammonia? Ammonia is just NH3. The nitrogen should have how many bonds around it? 3. So how many bonds is this nitrogen having around it? It has 2 from hydrogen, okay, and 1 from this benzene. So I don't have to like add this one there anymore. What about this one? It will still be there. Do you understand? So this is the structure of our what? Of our cytosine. Okay. Don't forget our pyrimidine, they are just what? Cut. Pyrimidine is known as what? Cut. Cytosine, uracil, and the thiamine. Now let's move to the next nitrogenous basis, which is the purines. Okay. So how do you know your purines? How do you know purines? There is this okay. Yeah, we only have 2 purines. We have 2 purines, which are the what? The adenine and the guanine. Okay, we have the adenine and the guanine. So how do we draw the structure, and how do we know that okay it is adenine and guanine? You can just use this code, which is what? Pure. You can use this code, which is what? Pure, which is purine. Pure for purine. Pure adagula. Okay, or if you don't know who Adagula is actually one of if you're a football fan, you don't have to have problem with this. Just use your pure Adagula. Okay, you don't have any problem with this. But if you are not a football fan, you can just pure good. Okay. But being a football fan, I prefer using the pure Adagula. Okay. Pure. What do I mean by pure Adagula? Pure Adagula is actually a white man. So is pure, that is white. So pure Adagula. So that is it. Or you use pure as good. That is to tell you that what we have adenine and what we have adenine and what and the guanine. So how do we draw these structures, and how do you even know how to draw them? From the word pure. The word pure is actually telling you something. The word pure is telling you something. What is the word pure telling you? The word pure is telling you that what these guys are used to what? To purify stuff, or to purify a particular thing or a particular substance. And if I want to purify something, probably like I have to like take it, like the thing should undergo probably like a filtration. So pure. For it to be pure, I hope you've written this down. Pure Adagula or pure as good. Adenine and guanine. Adenine and guanine. Okay. So pure. From the word pure, the first thing that should come to your mind from the word pure is that okay, pure. That means that what it should what undergo what filtration. Probably I should have something like this. Just look at this structure first, okay? Just look at this. Now when we talk about pure substance, for you to get a pure substance, so I can actually pour the thing inside here. So it will have to like pass through this place. It will get filtered, okay? And it will also what pass through this last place to be what pure. Do you understand it? That is, you understand what I'm trying to say, right? So it has to pass through here and here. So we have to filter 2 times for it to be pure, okay? We have to what filter 2 times before it can be pure. So we need what 2 structures. So when you hear the word purines, it means that what they have what 2 structures, not like pyrimidine that has what just a single structure. So how do we draw the structure of guanine? So for guanine also, we are still going to implement that pyrimidine stuff, okay? So how am I drawing this? You know, I have A and G. And when you look at cuts, CUT, okay? When you look at this, you notice that what A and G will be at the back of you. A and G will be at the back of you. That's to tell you that what both of them will not have double O the way uracil and thiamine has. Okay, see that is at the back of you also does not have double. It has only one O, and it replaced one of the O with what amino group. That is to tell you that what this guy also guanine. Abi now Guanine will not have a double O. Okay, it will only have what, one O, and replace the next one with what, amino group. What about adenine? When we get there, you are going to see it. So why did I draw two structures here? Because we call them purines, so we want to use them to filter. So the solution should pass through the first side and pass through the second side also. So for the first side here, this first side is just our normal pyrimidine structure. So purine is just pyrimidine and adding something else to it, so that we are going to have good this thing. Okay, so for the pyrimidine, you draw your N here. Okay, where do you put the next thing? 1, 2, 3. Okay, so we have another nitrogen here. So 1, 2, 3. I want to draw the structure of guanine now. Okay, now the next thing is for me to add oxygen. Add oxygen here. Okay, now will I add oxygen here? No, because why? Because the G is at the back of this U. I know, we have AG. I know, I have AGCUT. Okay, AG cut, that is Adagular cut. Okay, so I will have, instead of O, I will have what? An amino group. Do you understand it? And normally this thing should be like this, and this. Okay, but this bond here will be used by this what? Oxygen. Okay, so we have to remove it and put it here. What about these two guys? They will still be there, they are not going anywhere, and I hope you understand that. So the next thing is, let's come to this side. You don't have to stress yourself here. The only thing you just have to do is just add one nitrogen here and one nitrogen here. Why? Because like you will need a window for the water or anything that is entering here to go out, so that they can be filtered out. Okay, so we need a window here and a window here, which is our nitrogen also. Nitrogen. Okay, so this is how to draw the structure of our guanine. Why did I add a bond there? I just have to like put at least one bond there, just for it to make sense. So the next thing is, how do I draw the structure of what? Adenine. So this is this is the structure of your guanine. Okay, now the next one is the structure of what is it called? Adenine. Now looking at the structure of adenine, we have to be very careful. You'll notice that what adenine here is the last guy. First letter, the first letter is A. So you don't even expect the H should have any O. Okay, we don't even expect the A to have what? Any O. Why? Probably like let's assume when we have something like B, C, D to upward till when we get to U, we can have just one O, because they are not still up to U. But A is the first one, so it is not having any O. Okay, it is just having an amino group and what? Hydrogen. Do we understand that? It is having an amino group and hydrogen. So let's draw the structure. It is a purines, right? So it needs to structure the pyrimidine structure and another what? Filter guy. So okay, I hope you understand this. So how do we draw? The first thing is our double N. Nitrogen 1, 2, 3 here. Nitrogen. Okay, the next thing is, okay, what's the next thing? Should I add oxygen? No, so I will just add an hydrogen and NH2. So how many bonds do you think this guy will have? It will have 3 bonds. So it is nothing is taking the 3 bond, because hydrogen here, yeah, nothing is taking the 3 bond. Okay, so this is the structure. Okay, now don't forget our nitrogen and our nitrogen, which is our window. Nitrogen, and give one of them this. So this is how to draw the structure of our nitrogenous bases. Okay, thank you. So now also how do you know that, okay, when when A binds with C, how many bonds? When C binds with what? G, how many bonds? So very simple. So very simple. Let's do that. So now you have to change the this thing from ada, like for the last one I used what? Adagula cut. This cut is for the what? For the pyridine. Pyrimidine rather. The pyrimidine. Okay, and this AG is for the what? Purines. Okay. If you are talking about the pyrimidine only, you just talk about the cut. Okay. But when you are talking about the purine, you talk about the AG and the cut. Okay. You understand? I hope you understand it, because you will notice that what in the structure we have this thing, but we are still basically using the cut as our 1, 2, 3. Okay. 1, 2, 3. But now, this is Adagula cut, probably like Adagula's hairstyle. So now the next thing for us to do now is, how do we know that, okay, when A comes with T, it gives us this, how many bonds? C and G, how many bonds? This thing is very simple actually. What you just have to do here is just have to change it, turn this thing upward. That is, say, instead of AG cut, that is Adagula cut, you just have to say cut Gula harder. You have to cut him harder now. Okay. That is CUT cut GA, cut Gula harder. Okay. So this is still our 1, 2, 3. 1, 2, 3, 4, 5. So our A to T will be what? Our A is number what? Number 5. Minus T is what? Number 3. So that will give us, so it means that what they have 2 bonds. They bind with 2 bonds. Okay. What about the C to G? This is what? 4. 4. G is what? 4. C is what? 1. G minus 1. This will give us what? 3. So they have 3 bonds. So make sure you like the video, comment, and subscribe to my channel. Thanks very much, and watch out for more videos like this. Thank you.